The latest upgrade to the James Webb Space Telescope has revealed something far beyond the typical deep space images we expected. With its mid-infrared instrument, MIRI, fine-tuned to new levels of sensitivity early in 2025, JWST detected an unusual anomaly in the data coming from a distant exoplanetary system over 1,300 light-years away. At first, this anomaly was dismissed as a simple data glitch, but after careful review, the signals were confirmed and reconstructed into an image. This image has quietly stirred up significant excitement and concern within the scientific community. The frame was created using a combination of infrared reflections and chemical emission data, revealing what appear to be structured, symmetrical forms arranged in purposeful alignment. This contrasts sharply with the usual diffuse clouds or chaotic atmospheric patterns commonly seen on exoplanets. The organized geometry of the formations sparked numerous discussions between NASA, the European Space Agency, and independent physicists. Chemical analysis of the exoplanet's atmosphere showed traces of phosphine, methyl chloride, and acetylene, organic compounds that, in such harsh environments, do not have any known non-biological origins. These compounds often indicate metabolic activity or even industrial processes. Adding to the mystery, spectral data pointed to a dense, moving cluster near the planet's equator that moves counter to the planet's weather systems. What stunned analysts was not only the presence of these patterns, but their persistence over multiple orbits and days. These geometric shapes didn't just appear once and fade away. They rotated, dispersed, and then reassembled. A behavior that cannot be explained by natural weather or geological processes. In response, the Space Telescope Science Institute convened a confidential emergency review board. Sources close to the meeting revealed that raw data was sent out for independent verification. Leaked messages from a Nobel laureate involved with the MIRI instrument calibration stated bluntly that this was the closest anyone has come to imaging non-terrestrial engineering. If these structures are genuine and not artifacts or coincidences, then JWST may have captured the first visual proof of intelligent life beyond our solar system. Despite the gravity of the discovery, NASA has remained cautious publicly. Their brief statement acknowledged unusual readings still under verification, but gave no further details. However, a Freedom of Information Act request by civilian astronomers uncovered observation logs noting active patterns and variable infrared behavior inconsistent with natural causes, fueling further speculation. Soon after capturing the image, JWST detected narrowband radio frequency harmonics from the same region. After filtering out cosmic noise, these signals displayed regular modulation with mathematical spacing. The source wasn't linked to any known pulsars or quasars. And unlike natural pulsars, the transmissions were irregular, yet followed a pattern resembling prime numbers. The full high-resolution image has not been made public. Those with clearance, or who accessed, leaked versions describe the scene as terrifying, not because of what it looks like, but because of what it implies. The image shows a repeating lattice of hexagonal shapes arranged in concentric circles with a perfectly centered void. Some compare it to artificial coral or neural synapse maps. The symmetry is unmistakable. It is not random or geological. This discovery has had a profound psychological effect on the research teams. Internal memos mention the introduction of counseling services for staff, and several senior analysts have taken sudden, unexplained leave. A former project lead, speaking anonymously, revealed that the concern extends beyond the image itself to the implications if future missions confirm the findings. The European Extremely Large Telescope, scheduled to begin testing soon, has already shifted its priority to observe the same system. Scientists now face a difficult balance between awe and fear. This could be the most important discovery in human history. Evidence that we are not alone. But it also raises worries that what JWST captured might not be harmless. The presence of synchronized shapes, movements, and chemical emissions in a previously considered cold and lifeless system challenges many assumptions, not just in astronomy, but also in philosophy, theology, defense, and international policy. Multiple global space agencies are racing to replicate the observation. Japan's Subaru telescope and China's Fast Radio Array have requested observation time, while DARPA and the US Space Force have privately asked for extra orbital scans of the region for reasons yet undisclosed. Even theological institutions are involved, with reports of private discussions between the Vatican Observatory and the Pontifical Academy of Sciences. Portions of the image are believed to have been shared with the Vatican, which is preparing theological responses should the discovery become public. A troubling question looms larger with every passing day. If we can now see them, can they see us? The detected chemical emissions could carry signatures of our civilization, such as radio waves, light pollution, or thermal fluctuations. If we are now visible to distant observers, have we unintentionally accelerated the timeline for first contact? For now, JWST has transformed the question of extraterrestrial life from science fiction into scientific inevitability. This image might be just the beginning. Beneath JWST's polished data streams lie findings that even veteran astrophysicists hesitate to name, a potential collapse of the cosmic framework long relied upon. As more data comes in, unexpected patterns challenge our theories, suggesting that the early universe may have evolved in ways fundamentally different from established models. Galaxies, formed within just 300 million years after the Big Bang, are not only present but abundant, massive, mature, and often exhibit complex structures that standard cosmology says should be impossible. They have settled into forms normally expected to take billions of years, glowing with chemical maturity that defies current understanding. JWST's infrared imaging reveals that many of these ancient galaxies have converted almost all their gas into stars with astonishing efficiency, far beyond what modern star formation theories predict. The usual explanations involving dark matter, magnetic fields, turbulence, or ionization don't fully account for this rapid formation and organization. Some scientists now believe these galaxies are not rare anomalies, but the norm, prompting expanded spectroscopic surveys using JWST's instruments to study their light in detail. These surveys aim to clarify whether we're seeing typical galaxies operating under unknown conditions or something far stranger, possibly new astrophysical phenomena or high-mass star clusters masquerading as galaxies. By analyzing redshift and spectral lines, astronomers can confidently date these objects to the universe's earliest epochs, making their unexpected maturity even more unsettling. In response, theorists are modifying simulations to include new behaviors of dark matter and dark energy. Some suggest dark matter might have been warmer in the early universe, allowing faster structure formation, or that dark energy's properties temporarily changed, accelerating cosmic expansion and mass accumulation. These proposals challenge the fundamental assumptions taught in astrophysics and underpin current cosmological models. The possibility that primordial black holes formed during cosmic inflation seeded the rapid growth of galaxies is also gaining traction. This could explain the existence of supermassive black holes less than 1 billion years after the Big Bang, a problem that has puzzled scientists for decades. Perhaps most provocatively, some scientists are reconsidering the timeline of cosmic evolution. While the universe's age of 13.8 billion years remains supported, the pace at which crucial transitions occurred might have involved bursts of accelerated complexity rather than gradual, steady-state growth. This could rewrite the rules of causality underlying cosmological theories. To address these questions, international teams are feeding vast amounts of JWST data into computer models, adjusting parameters never before tested. The tension between theory and observation is growing, with the potential to open entirely new areas of physics. Yet the scientific community remains cautious, mindful of confirmation bias, and always seeking mundane explanations first, such as contamination or calibration errors. Upcoming missions like the Nancy Grace Roman Space Telescope will complement JWST's precise deep views with wide-field surveys to assess how widespread these unexpectedly mature galaxies are. Together, these efforts will help determine if these observations are rare oddities or signals of a profound gap in our understanding of the universe's infancy. Meanwhile, JWST is also studying exoplanet atmospheres, detecting possible biosignatures, like water vapor, ozone, and methane, which could revolutionize our knowledge of life beyond Earth. As these discoveries push the boundaries of science, they reshape how we see both the universe's past and its future. Despite all the progress, one thing remains clear. The cosmos is far stranger than we ever imagined. The James Webb Space Telescope was designed to peer deeper into space and time, but it has also challenged everything we thought we knew. Beyond galaxies and black holes, new layers of cosmic complexity are emerging, touching on the very quantum fabric of reality itself. As JWST continues to deliver surprising results, attention quietly shifts to even less explored frontiers that may hold the key to understanding our universe's deepest mysteries.